Okay. Today we will discuss about beta function. So we start the definition of beta function. So we write down the beta function defined by the integral and denoted by beta mn, and we write down as integral 0 to 1 x raised to the power m minus 1 minus x raised to the power n minus 1 into dx. It is necessary that the values of m and n should be 0. So this is the definition of beta function. Okay. So this definition is valid only when m and n greater than 0. So remember this definition. Now, after remembering this definition, we have some properties. So first we start the property of beta function. So we write down the properties of beta function. So we have first property to prove. We start with first property. So to prove that beta mn is equal to beta nm. So here we shall prove beta mn is equal to beta nm. So now we do the proof of this. So we write down that we know that by definition of beta function, we know that by definition of beta function, beta mn is equal to integral 0 to 1 x raised to the power m minus 1 minus x raised to the power n minus 1 into dx. Okay. So we have one property of definite integral. So we know the property of definite integral. So we use this property here. So property is that when we have integral limit 0 to a fx into dx, so this can be written as integral 0 to a f of a minus x into dx. So you can use this property or you can use the substitution. Okay. So one side we take as a property, that means we can understand this. So when we apply the property, so using the property, we write down here using the property. So when we use the property, so this can be written as beta mn is equal to integral 0 to 1. So we have function fx, so with this function can be written as a minus x. So here a equal to 1. So we compare this integral with this integral, so this gives a equal to 1. So when we write down a equal to 1, so this x can be converted into the form of a minus x. So means 1 minus x. 1 minus x raised to the power m minus 1. Second term, this is 1 minus x. So 1 is we write as it is minus, and this x we replace by 1 minus x. This x replaced by 1 minus x raised to the power n minus 1 into dx. So simply here we apply the property. So we write down this as 1 minus x raised to the power m minus 1, and this one to this one cancelled. So second term minus minus is plus. We have second term is n minus 1 into dx. Now this can be written into the form of definition of beta function. So first term we write down as x raised to the power n minus 1, और second term हमारा क्या रहता है 1 minus x raised to the power n minus 1 into dx. Okay. अब इसको क्या करेंगे, कंपेयर कर देंगे definition of beta function. So when we compare this by definition of beta function, तो जहां पर m था हमारा, अब m के प्लेस पे क्या आ गया, n आ गया, और n के प्लेस पे m आ गया. So this, so we write down by using definition of beta function. So we use the definition of beta function. So this can be written as beta nm. So this can be written as beta n comma m. So this is our proof. Okay. So this is our proof. So hope you understand. So we use the definition of beta function. So we know that. So here we have m. So this m we write down here, and this n we write down the here. Okay. So beta mn. Now, when when you are not aware about this property, so then you can use the substitution method. So that means we put 1 minus x is equal to t. So 1 minus x is equal to t. So that means the value of x equal to 1 minus t. When we differentiate this, so minus dx is equal to dt. Minus dx is equal to dt. Now we obtain the limits. So for lower limit, we have x equal to 0. So x equal to 0. So when we put here x equal to 0, so we see that 1 minus 0 is equal to t. So t gives us 1. So t is equal to 1. So this is our lower limit. Now we obtain the upper limit. So when you obtain the upper limit, so upper limit is 1. So put x is equal to 1. So put x is equal to 1. So we see that 1 minus 1 is equal to t. So 0 is equal to t. So means t is equal to 0. So the limits of variable t is 1 to 0. The lower limit is 1 and upper limit is 0. Now, so when we use the substitution, that means we have put 1 minus x is equal to t. So we move to the integral. So integral limit should be 1 to 0, 1 to 0, and first term is x raised to the power m minus 1. So x is equal to 1 minus t. So we know that x equal to 1 minus t. So we write down as 1 minus t raised to the power m minus 1. Second term is 1 minus x, 1 minus x raised to the power n minus 1. So what is 1 minus x? 1 minus x means t, t raised to the power n minus 1. And what is the value of dx? The value of dx will be minus dt. So the value of dx will be minus dt. Now, on the basis of this negative sign, the limit will change. Limit will change. We have the property of definite integral also. So we write down this as 0 to 1. Is negative sign के base पे we can change the limit. So first we write down the t raised to the power n minus 1, or second function we can write down 1 minus t raised to the power m minus 1 or dt. Okay. We know that the properties of definite integral. तो क्या प्रॉपर्टी होती है कि अगर हमारे लिमिट a टू b fx dx, अगर फंक्शन fx dx दे रखा है, तो a टू b वी कैन राइट डाउन एज ft dt. तो हम ft dt में लिख सकते हैं. बट हियर यहाँ पे फंक्शन हमारा हमने क्या लिया है, t में लिया है. तो वी कैन राइट डाउन दिस फंक्शन इनटू द फॉर्म ऑफ fx. तो वी कैन राइट डाउन दिस इनटू द x. तो x रेज टू द पावर n माइनस 1 और 1 माइनस x रेज टू द पावर m माइनस 1 इंटू dx. ये किसके इक्वल चल रहा है, बीटा एम एन के. अब बीटा की डेफिनेशन यूज कर देंगे. तो यूजिंग द डेफिनेशन ऑफ बीटा. तो बीटा की जब डेफिनेशन यूज करेंगे, तो यहाँ पर जो m था, या m के प्लेस पे क्या आ गया, n आ गया. तो दिस कैन बी चेंज इनटू n और m. तो हियर वी आल्सो प्रूव दैट बीटा एम एन इक्वल टू बीटा एन एम. सो दोनों में से जो भी आपको सुटेबल लगे, यू कैन यूज द method to prove this beta mn is equal to beta nm. Okay. So now we move the further properties of beta function. So further properties are also important property. So we move to the another property, property number 2. So to prove that, we have the property related to that. So to prove that beta mn is equal to integral 0 to infinity x raised to the power m minus 1 upon 1 plus x raised to the power m plus n into dx. Okay, so this is our property. So we shall prove this property by using the definition of beta function. So by definition of beta function, so we take the definition of beta function, we write down a beta mn. Beta mn is equal to 0 to 1 x raised to the power m minus 1 or 1 minus x raised to the power n minus 1 into dx. Okay, so here the limits are 0 to 1 और ऊपर limits क्या है 0 to infinity. So how to change this limit 0 to infinity? We can use the substitution. So when we use the substitution, so we use put x is equal to y upon 1 plus y. Okay, so we also see the result of uh, prove beta mn equal to x raised to power m minus 1 upon 1 plus x raised to power m plus 1. That's why so we take as y upon 1 plus y. Okay, so when we do the differentiation of this, so differentiation dx is equal to, so when we do the differentiation of RHS part, so we take as numerator upon denominator. The denominator into differentiation of numerator minus differentiation of denominator. So 0 plus 1 upon different denominator to the whole square into dy. तो क्या हो जाएगा dx? तो dx is equal to y to y cancelled हो जाएगा. So this can be written as 1 plus y minus y upon 1 plus y to the whole square into dy. So y to y cancelled. So this can be written as dy upon 1 plus y to the whole square. So dy upon 1 plus y to the whole square. अब देखिए हमने यहाँ सब्स्टिट्यूशन में क्या यूज किया था, x को यूज किया है y अपॉन 1 प्लस वाई. अब इसी सब्स्टिट्यूशन से हमें x की वैल्यू y की वैल्यू कैलकुलेट करनी है. तो हाउ टू कैलकुलेट y? तो व्हेन वी कैलकुलेट y, so we write down this as 1 plus y into x is equal to y. So this can be written as x plus xy is equal to y. So x plus xy is equal to y. So this can be written as x is equal to y minus xy. So x is equal to, we take y as common, so 1 minus x, and this gives us y equal to x upon 1 minus x. Okay, so y x equal to क्या था हमारा, y upon 1 plus y था, और y equal to क्या आ गया, x upon 1 plus x. So we remember these two things. Okay, so we will use in further. तो ये हो गया x हमने सब्स्टिट्यूशन यूज किया था y अपॉन 1 प्लस वाई, और y की वैल्यू ऑब्टेन करी तो x अपॉन 1 माइनस x. Okay. So now we see the limits. So we talk about the limits of the integral. लिमिट्स ऑफ द इंटीग्रल। अब इंटीग्रल जो गिवन इंटीग्रल था हमारा किसकी फॉर्म में था, एक्स की फॉर्म में था। अब हमें इसकी लिमिट भी चेंज करी है क्योंकि हमने सब्स्टिट्यूशन चेंज किया है। अब हम लिमिट से एक्स की जगह पे क्या पुट कर दें, जीरो, लोअर लिमिट के लिए। तो लिमिट ऑफ इंटीग्रल, तो फर्स्ट वी टॉक अबाउट द लोअर लिमिट। फॉर लोअर लिमिट, फॉर लोअर लिमिट वी पुट x इज इक्वल टू जीरो। तो इसी इस इक्वेशन में हम पुट कर देंगे, तो वी सी दैट y इक्वल टू जीरो अपॉन वन माइनस जीरो। तो दिस गिव्स अस जीरो अपॉन वन इज इक्वल टू जीरो। तो लोअर लिमिट हमारी क्या हो गई, y इक्वल टू जीरो। तो लोअर लिमिट इज y इक्वल टू जीरो। नाउ वी टॉक अबाउट द अपर लिमिट। तो फॉर अपर लिमिट, for upper limit we put x is equal to infinity. So when we put x equal to infinity, so we see that sorry, x equal to 1, like upper limit is x equal to 1. So we put x is equal to 1, so this gives us y is equal to 1 upon 1 minus 1. So this gives us 1 upon 0 or something upon 0 is equal to infinity. तो लोअर अपर लिमिट क्या हो जाएगी, y इक्वल टू इन्फिनिटी। तो लोअर लिमिट हो गई हमारी जीरो और अपर लिमिट हो गई इन्फिनिटी। सो वी रिक्वायर दीज लिमिट ऑल्सो, यस। so we move to the main definition. So this is our definition. So we can give as equation number 1. So we write down as from 1. So from equation 1 we see that beta mn is equal to, when we use the substitution, so this gives us integral 0 to infinity. Now put the value of x. X value is y upon 1 plus y. So value of x is y upon 1 plus y raised to the power m minus 1. Second function is 1 minus x. So 1 minus x means 1 minus y upon 1 plus y raised to the power n minus 1. And last term is dx. The last term is dx. So what is the value of dx here? The value of dx is dy upon 1 plus y to the whole square. So value of dx is dy upon 1 plus y to the whole square. Now we simplify this. So 0 to infinity, we can write down as y raised to the power m minus 1 upon 1 plus y raised to the power m minus 1. So we write separately into, when we solve this, so we can write down as 1 plus y minus y upon 1 plus y raised to the power n minus 1 into dy upon 1 plus y to the whole square. So y to y cancelled. So this can be written as integral 0 to infinity y raised to the power m minus 1 upon 1 plus y raised to the power m minus 1. And second term क्या हो जाएगा, second term will be 1 upon 1 plus y raised to the power n minus 1, or last dy upon 1 plus y to the whole square. So we see that the denominator is same, so we add the powers. So for numerator we can write down as integral 0 to infinity y raised to the power m minus 1 upon 1 plus y raised to the power m minus 1 plus n minus 1 plus 2 into dy. So plus 2, so minus 1 or plus 2 will cancelled. So this gives us integral 0 to infinity y raised to the power m minus 1 upon 1 plus y raised to the power m plus n into dy. अब सेम डेफिनेट इंटीग्रल की प्रॉपर्टी यूज कर देंगे, y में फंक्शन है तो इसको वी कैन कन्वर्ट इनटू द फॉर्म ऑफ x. सो वी राइट डाउन एज यूजिंग प्रॉपर्टी ऑफ डेफिनेट इंटीग्रल. So we write down as beta mn. Beta mn is equal to integral 0 to infinity x raised to the power m minus 1 upon 1 plus x raised to the power m plus n into dx. So this is our second property. So remember the result of this property. Okay, so we We'll discuss questions related to this property. Third property, similarly, we can write down the result of third property. Third property क्या है? To prove beta mn is equal to integral 0 to infinity x raised to the power n minus 1 upon 1 plus x raised to the power m plus n into dx. Okay, so similar we can prove this property. Okay, similarly we can prove this property. Okay, और आपने एक रिजल्ट अभी प्रूव किया ही था, क्या? बीटा एम एन किसके इक्वल होता है? बीटा एन एम के। उसके बेस पे आप इस रिजल्ट को भी प्रूव कर सकते हैं। ओके, so this is our third property. We write down this, use this. Okay, now move to the fourth property. Fourth property says that to prove beta mn is equal to twice of integral 0 to pi by 2 sine 2m minus 1 theta cos 2n minus 1 theta into d theta. Okay, so this result we also prove. So how to prove this result? So we prove this result by using the definition of beta function. So we use the definition of beta function also here. So by definition of beta function, ओके आपको जरूरत होगी इससे दो बार रिवाइज करने की। जब ओके व्हेन यू रिवाइज दिस वन और टू टाइम यू कैन इजीली अंडरस्टैंड। so we have the definition beta mn equal to 0 to 1 x raised to the power m minus 1 into 1 minus x raised to the power n minus 1 into dx. Okay, so here we use the substitution. So we need sin theta and cos theta, so we put x is equal to sin square theta, क्योंकि ओनली sin थीटा से काम नहीं चलेगा, तो वी पुट x इक्वल टू sin स्क्वायर थीटा और डिफरेंशिएट करेंगे इसको, तो dx डेरिवेटिव क्या हो जाएगा? डेरिवेटिव गिव्स अस 2 sin थीटा into cos थीटा into d थीटा, so dx can be replaced into 2 sin theta cos theta d theta. Now we talk about the limit. अब लिमिट के लिए लोअर लिमिट, फॉर लोअर लिमिट के लिए पुट करते हैं हम x इज इक्वल टू 0, तो पुट x इक्वल टू 0, so that means 0 is equal to sin square theta, so that means sin 0 0, so theta gives us 0, तो लोअर लिमिट तो हमारी 0 हो जाएगी। और अपर लिमिट के लिए, फॉर अपर लिमिट वी पुट x is equal to 1, तो 1 is equal to sin square theta, 1 equal to sin square theta means sin pi by 2, so this gives us theta is equal to pi by 2, so theta equal to pi by 2, sin pi by 2 equal to 1, so theta equal to pi by 2. Now we put into the given definition, so put in 1, so we write down put in 1, so we see that beta mn is equal to integral 0 to pi by 2 x means sin square theta raised to the power m minus 1 into 1 minus x sin square theta raised to the power n minus 1 into dx, so dx is 2 sin theta cos theta into d theta, so this equal to we can write down as integral 0 to pi by 2 sin 2 m minus 2 into theta. Okay, 1 minus sin square theta is cos square theta, and cos square theta, so this can be written as 2n minus 2 into theta. Okay, 1 minus sin square cos square into 2 sin theta cos theta d theta. So we can take 2 from outside from the integral 0 to pi by 2. Here sine raised to the power 2m minus 2, 1 sine here. So the power will reduce to the 2m minus 1, 2m minus 1 into theta. Or similarly for cos 2n minus 1. So 1 cos here, 2n minus 2 here. So into theta or d theta. So we have proved our result. Beta mn is equal to integral 0 to pi by 2 sine 2m minus 1 theta cos 2n minus 1 theta d theta. Okay. So we have some integrals related to that. So we will solve problems related to that also.